Now let's take a look at the Flip SOP workflow. We have all of the Flip fluids, Flip simulation available onto the SOP level as well. Let's see how we can configure that. As always, let's create an A geometry node, and in here first we need the source, and I'm going to use an A sphere for the emission. I'm going to lift this sphere a bit up, and to create this we have a flip solver. If you type flip solver, here we have it. Let's add this, and it requires the domain. We need the container, and for that I'm going to create a flip container node, and here we have it. Let's add this, and we need to connect all of these onto the required container and onto the collision as well. And if I were to visualize my flip solver, here you can see I can define the container size onto this flip container. Let's enable its parameter, and here we can define the particle separation, and I can define the size of my overall container. And right now it's not updating. We need to actually play this to have the updates, or we can just visualize the flip container. Let's visualize, and in here if I were to adjust, here you can see we have these flip container domain size, and we also have the gravity force built in onto this flip container itself, and we have the gravity, and it is going on to the minus of the y. And we also have the option for enabling the surface tension. Let's enable this. Here we can define the surface tension, and same thing, we also have the viscosity to create a viscous fluid like the honey or chocolate. Let's disable this. And to actually import these sources, we need to connect the source onto this last input. Let's add this and visualize the flip source, and here you can see our sphere has been imported as a source. And let's hit play, and here you can see after the bounds the source is cutting off. Let's go into the flip solver, and maybe let's add a collider. Let's add a ground plane. Let's go into the flip, and onto the collision we have the option to enable the ground plane, and right now ground is set to none. I can add the ground plane, and that will just create this for us. And let's hit play, and here you can see we have the collision. And same thing, we are visualizing our particle as sprites. So onto the flip solver, let's go into the visualization. We have the option to enable this point as sphere. Let's uncheck this, and now we are visualizing these simulation particles as particles. Let's enable the real-time playback as well, and let's hit play. And right now here you can see we are not continuously importing our source. We have this blob of fluid. It's going to be initialized at the very first frame, and then simulation is just taking care of all of the simulation. And to actually continuously import this sphere or this source, we have a node called flip boundary. Let's add a flip boundary node. Let's add this, and I'm going to connect this in between, and that will going to be used as a source. And the very last is for the sourcing, which means I do not need to connect this in here, and I'm going to connect this at the very last. And right now here you can see this flip boundary node is actually converting this polygonal piece of geometry into our source. Notice we do not need to create a fluid source node, a flip source node. If I type a flip source, here you can see flip dop source, and it is only designed for working if you are going to create your own dop network. If you are going to use this SOP workflow, this flip boundary will only accept this polygonal piece of geometry, and it will convert this into volume and particle for us. Let's go into the flip solver, and let's hit play. And here you can see we have the continuous emission of our source, and we have the ground plane. I can go into the flip container, and onto the particle separation I can lower this value down, and that way I can emit more particles. Let's lower this value down to 0.03 maybe, and here you can see we are emitting a lot more fluid particles. We have the same effect that we just built into this dop network. Let's go back, and onto the flip boundary we have some other option. We can add the additional velocity, and right now we have the scale velocity, which means that it is a multiplier for the incoming velocity. And if you take a look at the sphere, right now we do not have a velocity in our source. I can create that. I can add a point velocity node in here. Let's add this and let's connect this onto the point velocity. Right now it's set compute from deformation. I'm going to change this set to value, and I'm going to give a velocity onto the positive x. Let's change this to 1. And also I'm going to add a noise as well, as an animated noise. And now this flip boundary will going to be import our this velocity from the SOP, from this source into our simulation. And here as you can see, we have our this breakups happening in our fluid. I can go into the flip boundary node and I can scale my incoming velocity. If I were to increase this to 5, which means that we are just going to be increasing the scale of our amplitude, overall amplitude of our velocity. If I were to hit play, and here as you can see, we have a very chaotic motion because we are scaling our incoming velocities. Let's go into the flip boundary and let's change this to 1. Or I can just not use the point velocity and go into the flip boundary and add a velocity. I can go into the additional velocity and change this to 1. And what that will do, it will just give a velocity into our source. And here you can see, I'm going to just increase this value to a higher value so that we have a bit more exaggerated effect. And here you can see our velocity has been added and this flip boundary is adding them. I'm going to not add this, so let's change this to 0. Let's go back, and in here let's add another collider, because right now we are creating the ground plane onto the flip solver. If I go into the collision, here you can see we have the ground plane option to add. But to add additional collider, we can add a flip collider node. Let's add a flip collider, and here we have it. Let's add this, and we just need to connect this in between, and we need to put our this new collision onto this input. In here, let's say I'm going to add a rubber toy as a collider. Let's add this, and I'm going to connect this into our this collision geometry, and I'm going to move my source a bit up because right now it is intersecting. Let's move this up, and let's really reinitialize this flip boundary. And I think we are cutting off because of the flip container. Let's increase its Y size, and here you can see now we have increased our domain and our source is back. Let's hit play again, and now we should see the collision happening. And here you can see this source or this fluid is interacting with our collision geometry. And you can continue to add more and more collider. If I were to, let's stop this, and if you want to add another collider, I'm going to just add another flip collider node. Let me add a flip collide, and let's connect this in between. And this time maybe I'm going to add a sphere in here, and let's connect this onto this new collision. And let me find this sphere. Let's adjust its axis. First, maybe let's add a Y offset. I'm going to move this a bit up, and now we should see both of them. Now first it's going to be collide with sphere, and now it's going to be collide with this rubber toy geometry. And that's how you can import your collision. And to actually create the water tank effect that we had in here, if I type in here a flip tank, here you can see the flip tank that we just created. We can also create this onto this SOP level as well. Let's go into the flip solver, and here you can see we have the water line. Let's go there and enable the water line. And what that will do, it will just create a water line, and I can just increase the water line and it will just fill out. Right now we are at the frame number 24, so let's go back at the very first frame. I'm going to just play around with this water line, and here you can see we are creating filling out our flip with this water line. I'm going to stop this in here because right now the simulation is getting heavy. Let me stop this. Let's go back, and now we actually do not need the source imported in here. So let's maybe delete the flip boundary node as well. And let's go into the flip container, and I'm going to just default out my domain size by clicking on this middle mouse button. Here as you can see, we have our water in here, and right now it is colliding. I'm going to just stop this and let's rewind, and let's not use both of these, our collider. I'm going to delete out this sphere and let's delete both of them. Right now we have a gap in between. If I go on to the flip solver, and that is coming from our this narrow band. Right now we are creating the narrow band simulation, and to actually make our this water tank fill, I can go into the flip solver, and onto the advanced tab we have this option enable particle narrow band. Let's disable this, and now we are filling our this tank with particles. Let's hit play, and here you will see that we have our this particle filled. Right now our particle separation is too low. We are creating lot more particles. Let me stop this. Let's rewind. Let's go into the flip container, and I'm going to just default out to 0.1 so that we have bit more manageable particles. And now here you can see we are creating less particles. And same thing, if you want to create the particle forces, your pop forces to drive your simulation, you can dive inside the flip solver. Let's dive inside, and here you can see we have the force. We can plug all of the particle forces onto this force one. I'm going to add a pop wind node. Let's add a pop wind and connect this onto our this forces. Onto the pop wind, I'm going to just increase the amplitude to a higher value. Let's go back and hit play, and here you can see we have our wind force working. And that's how you can also apply your particle forces. Let's go into the test geometry, and maybe let's animate our this source or this collision. Let's add a transform node, and I'm going to just add a very basic translation. I'm going to start this below the ground. We need to first disable the dynamic simulation. Let's rewind, press and hold the alt key to add a key. Let's go a few frames forward, and let's move this up. Let's continue moving this up, and let's add another key. Let's go into the flip solver, and let's import this as a collider. I'm going to use a flip collider node. Let's add this, and that is our collision. Let's hit play, and here you can see our animation is imported, and we actually forgot to enable our dynamic simulation. Let's enable this, and let's hit play, and this rubber toy will going to be affect our these particles. And here you can see this rubber toy is actually creating the splash onto our these fluids, and that is the flip SOP workflow. That's how you can create the flip fluids right in here onto the SOP level.